All right, hi there. Hi, Samuel. I can't hear, could you hear me? I can't hear you. I hear a buzz, but I can't hear you. That sounds like it might be better.
Yeah, that's the webcam mic.
Okay,
I've got a better mic that I'm trying to use. It's just not working for some reason.
okay. All right, well, I'm going to, so we have my main computer is on and a telescope is on, and I'm going to go down. I have yeah, that's all working good. I'm going to connect my other laptop that's down in the observatory now.
Okay,
It's already tracking Jupiter.
great.
So, and it's on, it's on a screen. So I'm going to go down there, connect it.
Okay, sounds good.
Hopefully that'll. Yeah, I was playing with it earlier just to see how good an internet connection we had down there. It was marginal. I think maybe I fixed it, but we'll see. If the voice isn't good, you and I might want to have a cell phone available. So when I'm down there, at least you and I can talk.
Oh yeah, no, I'll definitely get it worked out.
Yeah, okay. Well, I'm going down right now and
Okay.
and getting turn on the Zoom down there.
Great. I think it's working now.
Test, test, test.
Is it actually working through the microphone?
Let me test it again.
Is it actually working through this mic? I think it is.
Is it working?
Yes. No. Sure that it is. Hello. Yeah, it is. We're good.
Great.
Thanks, love. What happened? Just wasn't working on the front plug?
You know what? I wonder if that front plug is messed up because when I tried to plug this into it, I think I was getting the same thing.
Oh. That makes sense. Okay, as long as we're good.
Look.
Hi.
Oh, here we are.
We're recording. Just so you know. Thanks for your help. Do, 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 do. Testing. Testing. 1, 2, 3. Testing. 1, 2, 3.
I don't know if you can hear me. Can you,
I can, Mike. I can hear you just
Samuel?
fine. Yep, I can hear you.
Okay, great.
I've got my
Okay,
volume.
I'm going to put it on screen share then. Yeah, so that's been the weak point of being down here is the audio.
Yeah.
But I'm going to do screen share and we'll get Jupiter on here.
Great.
So you've got to enable me now.
Oh, yeah. Let me do that. Okay, you should be good to go. Yeah, I can see it.
Yeah, so you see, I have to do some adjustments on the camera, but I'm going to leave it this way to start so you can see
Okay.
the planet and 3 of the moons.
Yeah,
And I
looks
think
good.
we'll leave it that way to start.
Great.
And once we do, we'll turn down the gain on the camera, and then we can actually see some detail on the planet itself.
Yeah, I think and it looks like Io is actually in an eclipse phase right now, so we might even be able to see that. Yeah, Io is right out in front of the planet right now.
Oh, is it?
Yeah.
Okay. I don't think we're going to see that level of detail, unfortunately, but
That's okay.
okay. Well, that's working good. So I'm going to go back upstairs, and once we start the talk, I'll come back down here. I'll just leave this running like this.
Okay.
And
Sounds great.
so we'll start with these the 2 planets, which are yeah, it's not, well, we still have 20 minutes before 10. It'll get darker by then.
Yeah.
Hey, kiddo.
Hey, Dad.
How are you?
I'm good. How you doing?
Clear skies tonight?
Yeah, it's beautiful out.
Wonderful.
Yeah, you should already be able to see Jupiter up there. Mike just set it up.
I see it.
Yeah. How you guys doing?
Hey, Sam.
Hey, Wayne.
We just took a walk outside. It was a beautiful sunset.
Oh, nice.
Sat outside. Hey, Heather, how you doing, Ed?
Good. How are you guys?
Excellent.
Yeah, we're out at the tiny house right now.
Nice.
I can tell.
Yeah.
It's a nice place to be.
Yeah,
Love
I mean,
it.
especially because I'm looking at the Grand Teton right out the window here.
Really. Is
Great.
there enough light to see it still?
I can just barely see the silhouette.
Yeah.
That's to the west of you, isn't it?
Yeah. Yeah, Heather's got a pretty awesome view out her back door, looking right at the
Nice.
Grand Teton.
Is that Jupiter we're looking at on the screen?
Yeah, and you can see 3 of the 4 moons. One of the moons is right in front of the planet, but that is that's Ganymede right there, and then
That's what I would have guessed.
Europa.
Just to the left of it at like 8 o'clock, right?
Yeah, and then the one way off to the right is Callisto.
Way off, yeah.
Yeah,
I
way
see
over here.
something to the left of Ganymede.
Yeah, that's Europa.
Wow.
Yeah.
Yeah, so what we're doing, we're looking at live view from the camera.
Good evening, Mike.
Hi
Steve
there.
here.
Oh, hi, Steve.
It's a great view.
Yeah, and once we'll start with this, and then I'll go back. I'll go back down there and we'll dim the exposure. You know, there's another, I don't know if it's real or not. Let's see, down below, like at 7 o'clock, maybe 6:30. No, excuse me, at 7. Yeah, 6:30. Is there another planet down there, or is that just a bit of dust on my screen?
You mean
I
another
can't-
moon?
No, I think it's,
I can't see it from here.
yeah, I'm looking at myself. I don't think it's there. Okay, anyway, then I'll dim it. So what we're going to be able to see on the planet itself is a couple of the darker bands. That's about it.
Cool.
But it's overexposed right now so that the moons are visible. But the planet is blown out, so.
Can't get it all. So Mike, I meant to mention this to you at some point tonight. I got another call from John McQuillan today. He's the guy who donated the 25-inch Dobsonian to us a couple of years ago.
Oh, wow, okay.
So today he donated a sky chair. Excuse me, a star chair. Do you know about these things?
No,
They're pretty sweet. It's a motor-powered chair run by a joystick. And
Oh,
it's
God.
got a little hood on it that you can attach a pair of huge binoculars, 28 by 110s. And so you can
Wow.
use this little joystick and like recline the chair to point the binoculars up in the sky and slew around, and it's connected to some digital setting circles. And so you can actually, you know, bring up an object
Wow.
you want to go to and hit go to, and it slews you over there and allows you to look at stuff. It's a lot of fun.
That was nice.
It actually it actually
Yeah,
points it for you. You're
Yeah,
saying.
it's got, you know,
Cool.
probably one arc minute
Yeah.
accuracy, so you have to do some fine tuning, but it's pretty sweet. It also comes with a 7
That's still
foot,
pretty damn good. You know, one
clam
arc
chip.
minute is, yeah.
Yeah, it's not bad. It also comes with a 7 foot clamshell Astrohaven non-motorized observatory dome.
Really?
Gosh.
So now I've got to figure out where to put that until we get
Where to
started
put it,
on
yeah.
Snow King.
Yeah. Yeah, it's
Yeah.
not something you're gonna truck around for every
No.
show, though.
No, I got to figure out how I'm going to mount it somewhere. I don't know.
Yeah.
I might try to figure out if we can actually mount it on top of one of our trailers. I think that'd
Oh.
be pretty cool.
Yeah.
Anyways, yeah, we already have the chair and the binos in the Wyoming Stargazing office. I got to find a place for the clamshell dome before next week.
Did he give you the binos with it, Sam?
Yeah.
Wow.
Yeah. All in all, it's about $10,000 worth of equipment.
Incredible.
Yeah.
How powerful are the binos?
They're 28 by 110.
Oh, okay.
Yeah, the Oberwerk, whatever, however pronounce that brand. They're really nice.
German?
Yeah. Yeah, they're pretty sweet. It's going to be a lot of fun.
What does the guy do,
I
Sam?
have no idea how many people are gonna show up tonight, but
Oh, yeah, we'll see. Well, he does astronomy now. He has his own private observatory like Mike does. I think he's got an 18-inch in his observatory. I think he mostly just does visual observation. He does some photography, but yeah, he just has fun in his observatory.
Cool.
Yeah, so his backstory is that he was one of the guys who helped design hypertext protocol.
Wow.
Yeah.
HTTP.
Yep. Yeah. So yeah, he was there at the beginning of the internet, and yeah, did consulting work for a while until he didn't have to do it anymore.
yeah, so one thing I can do, I'm not sure what will work. I can actually take pictures, but I think the live view is pretty equivalent to the picture.
Yeah,
So it's
good.
probably not worth the bother.
Yeah, I mean, unless there's some advantage in the like the resolution of the pictures.
Yes, what we could look, I looked at a couple of them. Saturn is, what you can see when you will look at Saturn, you'll see, you definitely see the rings and the gap, where the rings and the planet are, but you're not going to see detail on the rings or the planet. Unless,
Yeah.
you blink your eye, maybe, there might be something there, but at least we'll see the ring itself, the rings
Yeah,
itself.
that sounds great.
Yeah. Okay, I'm going to step away for 30 seconds, or a minute or two, and I'll be right back.
Great. Yeah, no rush.
Have you been doing some stargazing programs this week, Sam?
Yeah, 1 or 2 each night. Couple nights we've had 3 or 4.
Good. Any big ones?
No, all small groups. Actually, no, we've got a wedding going on tonight for 30 people.
Wow.
Yeah.
That's a big payday.
Yeah, they only wanted 1 telescope, so it's not that big. We usually would do 2 or more telescopes for a group that large, but they
That's
wanted
not a lot of
smaller.
telescope for 30 people.
Nah, I tried to tell them that they didn't want it, so I'll just have to stand around.
If I ever get married again, I'll make sure I have plenty of telescopes.
Yeah, I recommend our all-inclusive stargazing package, which comes
Okay.
with 3 telescopes and lots of other good things.
Champagne, hot chocolate.
Well, not right now during COVID, but yeah, at other times I think we can do those things.
Okay.
Is it cool there now? I saw Mike had a cap on.
Yeah, so Mike is kind of right at the base of the Teton range.
65 here.
So it's 65 here. I bet it's in the 50s where Mike is, and he's been outside. Yeah.
Probably still 80 here.
I mean, it was in the mid 80s today. It was really toasty, but it cools off a lot when there's no clouds after it gets dark.
Looks like Bjorn wants to go out. How's your dog, Sam?
He's good. He's asleep right behind me. He's starting to make some grunting noises because he wants to go to sleep, and we're not turning the lights off for him.
He's irritated.
Yeah, he makes these kind of groans when he's tired and he wants to go to sleep. Kind of like a toddler.
Yeah.
Or grandpa.
Yeah.
So you're looking at Jupiter, 3 moons. Yeah. Yeah. That one's, that's apparently Europa. So Samuel, so you know what we're looking at here, although I can describe it. We're doing this through a 12.5-inch telescope, and it's a camera with a 2.5 power Barlow and the camera and live view. It's a Panasonic camera.
Yes, we've got Jupiter and 3 of its moons. The 3 little dots are the moons. The brightest one just to the left of Jupiter is Ganymede, largest moon in the solar system.
In fact, it's large. Is Ganymede actually larger than Mercury?
It is. Yeah, larger than the planet Mercury. And then Europa, tiny little dot just to the left of Ganymede. And then way back over on the right, pretty far out, is Callisto. And the 4th Galilean moon, Io, is actually right in front of Jupiter right now. And if we had a higher resolution image, we could actually see the shadow cast by Io on the planet.
Yeah, there's just too much turbulence in the sky to see.
Yeah.
Even when I darken this, you'll see the planet is just jumping around.
Yeah.
Because of the turbulence. Yeah, you know, one of the things about where it is right now, it's also low in our southern sky, so that doesn't help.
Yeah. Yeah. On the best of nights, we can actually see eclipses like that through the 20-inch telescope when the
Okay.
seeing is really good,
Okay.
but just barely.
Yeah.
And more easily when it's Ganymede or Callisto causing the eclipse compared to Io and Europa, which are much smaller.
Right. Yeah, I stressed to people in my email that we're starting at 10, so I whether that's going to be a problem and people are going to sign in at 10:30.
Well, I sent out a correction time email as well, so.
A little concerning that we only have 3 people at the moment.
No, it's Jackson punctual.
Let's make sure you.
And people seem to be logging in right now.
Hi, Sam.
Hi, Deborah, how you doing?
Okay,
All right.
I
Got it.
just sent you an email of YouTube video from the American Museum of Natural History Astronomy Department.
Oh yeah, I see it.
Yeah, the virtual
Oh,
trip.
field trip through the Milky Way. That looks fun.
It's fun. It's really, so take a look when you have a chance.
Yeah, I'll check that out. Thanks for sending it along.
Sure, good educational material,
Yeah,
you know, for your educational bend.
yeah, I like it. Thank you.
Yeah.
How's your week been?
Good. Yeah. Yeah. Beautiful weather.
Yeah,
Nice walks.
indeed.
Yeah. And you?
It's been a busy week, but a good one. Lots of stargazing programs, and yeah, we shot
We're
some
up to 8
footage
for
of Mike's observatory
Right, so
last
you-
weekend. So I've been
Marsha Cash now. All right.
doing some
My-
processing of those videos.
Ah. Okay. I'm gonna leave you for a minute,
Okay,
but
we'll be
do
here.
it sure. Okay. Yep. The video is off, right?
Yes, it is.
Okay, good. Okay.
Um, so,
So folks, we'll get started in just a few minutes. Thanks for being here. Going to start off with Jupiter and Saturn tonight. I think Mike just went down to the observatory to get the cameras going. Hey, hi, Curtis.
Hey, how are you?
Oh, good. Good to see you.
Good to see you too.
How you been?
Having fun?
Nice. I'm
It's
glad
a
to
weird time. What can I say?
it is a weird time.
Been
Definitely.
growing vegetables just for fun. Something to do.
Nice.
How's the
Remind me
sky
where-
out there?
Oh, it's been beautiful.
Good.
Yeah, this last week has just been gorgeous. Really, the whole month of July was spectacular, and August has been really nice as well.
I'm looking forward to seeing what you guys are going to do.
Yeah, it should be fun tonight. I'll start with the planets and then take it from there.
Hey, how did the town meeting about, keeping the tram going until 1 a.m.? Did that work out?
Yeah, thank you so much for sending in your comments. So what they decided is that they would be happy to keep it going until 1 a.m. as soon as the observatory gets approved by the Forest Service.
Oh, okay.
And that'll happen in a couple months. So they were really clear during the meeting that they fully support the observatory and want to give us access to it, and the gondola is the way to do it. They just they didn't want to overstep their bounds and
Mhm.
approve an operational time before the Forest Service actually approved the observatory.
Sure. That makes sense.
Yeah, I think so. But yeah, we got a lot of letters of support, including yours, and I think that was really persuasive. So thank you so much for doing your part.
Oh, I'm glad to help.
Yeah, I really
It
appreciate
makes
it.
total sense.
Yeah. So the town just approved the gondola and the zip line that the ski resort wanted, and that's actually going to pay for the observatory.
Oh,
So
fantastic.
yeah, really good progress, and now we just need the Forest Service to finish their environmental impact assessment, and we should be good to go.
Hi, I'm Curtis Swan.
So Curtis, have you found that the Worldwide Telescope has been getting more use during COVID at all?
I don't watch the traffic numbers because it's really international.
Yeah.
But I imagine it's like a perfect vehicle to be able to look anywhere. I mean, you can look at the moon and see extremely high resolution digital elevation map imagery. So it looks like you're actually over the moon.
Cool. Mike, you about ready to get going?
I think so. I've been losing you, unfortunately. So my connection has been a little shaky. But I think we could probably get started. I tell you what I'm going to do though. I'm going to go down to the observatory now,
Okay.
and hopefully we're not seeing that screen share at the moment. So I may have lost a connection down there. I'm not sure.
Okay. Well, I'll introduce everything, and as soon as you
Okay.
get it back up, we'll go for it.
Okay, I'll tell you what I'm going to do is I'm going to connect. I'm going to give you a call. Yeah, you have your phone there?
I do.
Okay. Yeah, your screen is frozen, unfortunately, right? Well, it's jumping around.
Yeah,
Okay,
we can
well.
still see you okay.
Okay,
Maybe I'll stop my video and see if I'm sucking bandwidth for you.
No, I don't think it's you, Curtis. I think it's just
okay, all right.
out in the boonies here in Jackson. All right, well, welcome everybody. For those of you who don't know me, I'm Samuel Singer. I'm the founder and executive director of Wyoming Stargazing. Welcome to virtual stargazing tonight. Mike Adler, who you just saw, is headed down to his observatory to get the screen connected that he has hooked up to his telescopes and cameras. We're going to start looking at Jupiter and Saturn this evening, and then we'll move on to some deep space objects. And if there are any requests or questions throughout the evening, feel free to put them in the that's Mike just calling me. Hey, Mike.
Observatory, so if we can't talk down here via the Zoom, we can converse by the phone.
Sounds good.
I'm crawling in right now.
Lower the sky. My movers are down.
Yeah, we can hear you in the observatory now. So anyways, feel free to post questions and any requests for objects in the chat window, or feel free just to unmute yourself and ask a question directly. Either way is totally fine. So while
I got a
Mike
question.
oh, go for it, Curtis.
Is it good for you to have like more and more people coming to these virtual sessions? I mean, I didn't want to, tell too many people, but
yeah, the more the merrier.
Okay.
Yeah, we would love it if the audience keeps getting bigger and bigger. That would be fantastic.
Okay, good. Because I'd like to share it on social media. So I think it's a
Yeah,
great
thanks
thing.
for asking. Yeah, spread the word wide and far. So while Mike is getting that going, I wanted to share some of the images that the Juno spacecraft has recently taken of Jupiter. And the really cool thing about the Juno mission is that all of the raw images that the spacecraft took were made publicly available. And it was actually amateur and professional photographers, astrophotographers like Mike, who have been taking those raw images and processing them and then putting them out to the public. And so Mike has done some absolutely amazing processing of some of these Juno images. And so I'll share my screen here with you, and we'll be able to take a look at some of those. So hopefully y'all can see that one. So that's of the southern temperate region of Jupiter. You can see the classic great red spot in the upper right-hand corner. That's the giant anticyclone that's been spinning on Jupiter for at least 350 years, maybe longer. We don't really know for sure. It's showed some signs of getting smaller, but we don't really know how long it's going to last or when it will finally fade away.
Those clouds are really fractal.
Aren't they incredible?
Yeah, the more you zoom in, the more you see the details.
Yeah, there's just an extraordinary amount of detail on them. I'll bring up another one now. Hold on one second. Let's get to find where I put them all.
Did you save them to the desktop?
Yeah, they're on a, oh, here we go. Now I see where they are. There we go. All right. So here is Jupiter's south pole. I think this is probably my favorite shot from all of the Juno images that were released. And it's because of this bluish green color. Was just not a color that I was really expecting to see much of on Jupiter. I don't think anybody was. Really no one had seen the south pole of Jupiter before these images came through. And
Crazy.
So, yeah, the exquisite detail. And these are all just basically cyclones and anticyclones, just storms on the south pole of Jupiter. And so, yeah, I've looked at this image lots of times, and I can't get enough of it.
Yeah, the bigger you make it, the more you see.
Yeah, I'll zoom in a little bit so we can see some more detail here. If I can figure out how to do that.
Try a control and scroll wheel. Control or alt.
There we go.
Yeah. Whew.
Was that painted by Van Gogh?
It kind of looks like it, right? It almost looks like Starry Night. But yeah, this is a real image of Jupiter's south pole. I think Mike. Oh, go ahead, Mike.
Yeah, I was going to say this image actually won an award on Wikipedia as one of the 5 best science photographs of the year.
I don't know if you all could just hear that, but
This
Mike
image actually won an award on Wikimedia.
I think you said, Mike, it was one of the 5 best.
From the U.S. submission to the Wikipedia Science Contest this year, and then it's now being submitted to the international contest. So in some months, we'll find out what happens there too.
Nice.
So Samuel, I don't know if my internet connection down at the observatory is good enough to see it right now. We ought to try to see if we can see Jupiter.
Okay, so I'll stop sharing my screen, and you can try to share yours down there.
Okay.
What's that?
All right, Mike, see if you can share now down there.
Okay.
Sam, what was that last photo?
So that was a picture of the a zoom in of the North Temperate region.
Is it Jupiter that has the hexagon at the poles?
That's Saturn.
Saturn. We talked about that.
Not yet, Mike. Oh, there we go. Now it's coming up.
Yeah, this,
Now we can see it.
All right. Well, Samuel, you can describe what we're looking at here.
all right, well, Samuel, you can describe what we're looking at here.
Yeah, so hopefully everybody can see this screen share that Mike's put up. Now, this is a real-time view of Jupiter. The big glowing orb is Jupiter. And just to the left of Jupiter, you can see one small little dot. That's its largest moon, Ganymede. Actually, the largest moon in the solar system, larger than the planet Mercury. And then way off to the right, on the right-hand side of the screen, the black window, you can see another little small point of light. That's the moon Callisto. Mike's got his cursor right there. And then Io is actually right in front of Jupiter right now. So we can't see Io. And Europa should be just down to the left in the left-hand corner of the screen. I can't quite see it.
I can't either at the moment.
But it's right where Mike's cursor is. We were looking at it earlier. So to actually get the moons to show up, we have to overexpose the image of Jupiter.
Right.
And so that's why we can't see any surface detail on Jupiter right now. But it allows us to see the moons. And Mike, did you want to try a shorter exposure time? I think that's what he's doing right now. So we might actually get to see a little surface detail on Jupiter. Nothing like the pictures that we were just looking at.
I just boosted the gain, so you can now see Europa.
Okay.
Oh yeah, there it is. Yes, now you can see Europa in the bottom left-hand corner.
That's flickering, but. Okay, I'm going to do just the opposite. I'm going to reduce the gain so we can try to see some detail on the planet itself.
Sounds great.
Great. Oh, good. We can see it.
You know, and I said Io was right in front of the planet. I think I see Io poking out on the far left-hand side right there, right on the limb of Jupiter.
Yes.
That little dot right there, I think, is Io.
Mm-hmm.
Oh, there we go. Just barely see one of the cloud bands maybe there on the planet.
Mhm.
Oh yeah, right there.
When you need an experienced injury attorney, you need Brent Gordon. The attorney at Gordon Law have helped thousands of injury victims recover cash.
Looks like
Sam,
Mike's playing. Oh, go ahead, Curtis. Yeah.
what's the aperture and
We're looking through a camera hooked up to a 12-inch telescope.
F?
Oh, the F ratio on that, it's a plane wave. It's
Oh, it's
probably
plane wave.
probably F2, F3.
Fast.
Yeah.
Yeah.
Yeah, I'm afraid it's just a fuzzy blob. Yeah, last night I could see the bands on. You can barely see them. One right here and one right there, but it's not good.
Well, maybe we can go over to Saturn, Mike, and then maybe a little bit later in the evening when Jupiter's higher in the sky, we can try it again.
Too good at the moment, unfortunately.
Yeah. So it sounds like we're having a little bit of connectivity issue with Mike down his observatory. Just lost the screen share, so hopefully he'll get that back for us in just a minute and we can take a look at Saturn. Can you hear us down there, Mike?
Yeah, I'm changing the location to Saturn, so
okay, great.
Now it's going to go all the way around. Okay.
So while Mike is slewing the telescope over to Saturn, I had just pulled up a picture that the Hubble Space Telescope just took of Saturn a couple weeks ago. I think it was on July 23rd, the picture got released. We're not going to see this kind of detail tonight, but I wanted to show you what Saturn looks like through the Hubble Space Telescope. It's pretty awesome. So there you go. So you can really see the individual rings, separation between the rings. This big gap here is called Cassini's division. We can actually see that through our telescopes just with visual observing without taking pictures at all with our 20-inch scopes. But as you might know, both Jupiter and Saturn are gas giants, similar materials that stars are made out of, hydrogen and helium. In the upper atmospheres on Jupiter, all the detail in the clouds we were seeing, there's actually a lot of ammonia as well. But once you get below the cloud layers, which I think are only about 50 kilometers thick on Jupiter, it's hydrogen and helium all the way through. But the rings of Saturn are not hydrogen and helium. The rings of Saturn are rock and ice. And the chunks are just too small for us to see them even with the Hubble Space Telescope. And so they look like solid rings, but they're not at all. Just billions of chunks of rock and ice all orbiting around Saturn in unison. You can also see a couple of Saturn's moons here, one down below Saturn and then one off to the right. I'm not sure which moons those are. Saturn has quite a few moons, 82 official moons right now. I think 53 of them are actually named and another 29 are provisional moons. So Saturn, again, is the king of moons in the solar system. Jupiter comes in second with 79 official moons. So lots and lots of moons. most of which are pretty tiny. But there are some enormous moons. As I mentioned before, Ganymede, the largest moon on Jupiter, is larger than the planet Mercury. So it's the biggest moon in the solar system. And Saturn has another gigantic moon, Titan, which you may have heard about, the Cassini spacecraft that visited Saturn about a decade ago, sent a probe down to the moon Titan, the Huygens probe, which landed on Titan and sent back some incredible images of liquid ethane and methane rivers and lakes on the surface of Titan, which was pretty cool. And there was actually a Hollywood movie made several years ago, I think just called Titan or Titans. And it's a, kind of a dystopian, futuristic movie where life is going to be ending on Earth and we've got to figure out how to survive on Titan. And so these mutated humans are sent to Titan to see how they can survive. Probably not too realistic, but interestingly enough, Saturn, the moon of Saturn's moon Titan does have a really thick atmosphere, much thicker than Earth's, and so you wouldn't actually need a spacesuit. You would need an oxygen mask to, or a mask that could give you the right composition of our atmosphere to breathe through, and then some really warm clothes. But you wouldn't have to worry about the difference in, atmospheric pressure that astronauts have to deal with when they're out in space. You could be just fine on Titan. It'd be like walking, I think, about 10 feet deep in a swimming pool. So pretty thick, but doable. Mike, any word on how you're doing down there?
Okay, we're not going to see Saturn tonight. Unfortunately, the camera sticks out so far from the telescope it interferes with the mount. So Saturn just happened to be in the wrong spot in the sky, so I can't get to it. So we're going to move on to the rest of the program.
All right, sounds good. Do you need a few minutes to get the other telescope set up? Sounds like we're still having some connectivity issues with Mike tonight. So while Mike is getting that sorted, let me go over to the Wyoming Stargazing website. Some of you may have seen some of this stuff on previous virtual stargazing programs, but if you don't already know, Wyoming Stargazing is a 501c3 nonprofit organization. And in addition to the in-person programming we do here in Jackson, we do a lot of virtual programming to folks all over the country and even all over the world. And in addition to the virtual stargazing programs, we've got a bunch of other programs that we record and put up on our YouTube channel and Facebook page for your enjoyment and edification. And all of that information can be found on our public astronomy program webpage here. So if you're interested in learning more about all the programs we offer throughout the month, you can go to wyomingstargazing.org and check out all the different opportunities you have to learn about different aspects of astronomy with us. And then I also wanted to mention that this month, Wyoming Stargazing is involved with the big community fundraising event with the Community Foundation of Jackson Hole. We have an opportunity of getting all of our donations matched to about 50% throughout the month of August and into the first couple weeks of September. And so if you enjoy our programming and would like to support us, all the information about making a donation that can get matched is right on the homepage of our website. And it looks like we got Mike back, and so I'll hand it over to him. And we might have just lost him again. Are you there, Mike? Yeah. Well, we'll give him a moment. Hopefully he'll join us in a moment. So any questions about Jupiter or Saturn while we're waiting for Mike to get ready here? Oh, yeah, I just saw that Deborah asked about the hexagonal storm on Saturn's pole. Let me bring up a picture of that because it's pretty cool, actually.
Here and unmute.
Hi, Mike.
Hi there. Yeah, my neighbor plugged the cameras in I dropped out of so I'll be trying to come back up.
Okay, sounds good. Yeah, just let me know when you're back up. Yeah, Mike's having some connectivity issues. It sounds like his neighbor might be using some connectivity. Yeah.
Okay, well, I'm back up
Oh, he's back.
again. So we are. But I would move on quick.
What would you suggest? Should we just jump into
What would you suggest? Should we just jump into the nebulas?
Yeah, let's do either the Trifid Nebula or the Lagoon Nebula.
And you might as well do M22.
Yeah, we could do M22 or M13 as well.
Yeah.
Okay, yeah. So I got to minimize my screen to get to the.
You let me know when you're ready to share, Mike.
Yeah,
We'll be here in the bathroom.
So this hexagonal storm that that Deborah asked about is really fascinating. There's still a lot we don't know about it. This image here actually shows that it has a kind of a bluish tint to it, similar to what we saw on the south pole of Jupiter. And I cannot remember right now the theory behind the shape. Curtis, do you you know it off the top of your head?
No, I don't. The first time I saw it, I was astounded too.
Yeah, I'm gonna have to look it up again. But it yeah, was definitely a surprise to a lot of people. And it really does have this incredible shape to it, and a bluish tint compared to the rest of Saturn. The other interesting thing that I remember about it, let's see if there's a cool, yeah, here's the comparison picture. So it's actually changed color over the years. Whoops, I thought I was gonna get a bigger. Here we go, now we'll see a bigger image there. So yeah, it was kind of a greenish bluish color and then became more orange. So it's changing a lot. Definitely not something that's static. Mike, are you ready to?
well, I am. Okay, so I got the telescope moving to M16, the Eagle Nebula.
Okay, I'll let you share your screen then.
Okay.
You should
Hopefully,
be able to do
my
that now.
internet will hang in there.
Yeah, I'm gonna hang up the phone so I'm not hearing you twice.
Okay. Yeah. Okay, so we're going to take a suppose we're going to take a single picture, 20-second picture of M16. So
Nice, the Eagle.
you're
Map.
seeing my screen right now?
We are, Mike. Yeah.
Okay, good.
Yeah, we see
All
the,
right,
the
maybe
camera.
you'll,
Yeah.
good. Yeah, that's what you want to be looking at. Okay, so we'll check that out. I remember last week or 2 weeks ago, we looked at the Bubble Nebula. That came out actually amazingly well. We
Yeah, let's do that again too.
we have to do that. Oh, you know, I little detail is I haven't, when I crawled out of the observatory, I forgot to
Lens cap?
not the lens cap. The big version of the lens cap. I didn't open. I haven't
Oh, the dome.
had to reopen the dome. The dome. It's hard to crawl out of it, so I closed it up a bit. Now I have to reopen it, and only seconds here. I'm now reopening my dome. Fortunately, I can do all of that from inside the house.
Oh, that's good.
Okay, we'll have to take another picture. All right, here we go. Start.
So you said M16, Mike, the Eagle Nebula?
M16, the Eagle Nebula, yeah.
Yeah, so some of you might be familiar with the famous Hubble Space Telescope picture of the Pillars of Creation. That's part of the Eagle Nebula. And I think we'll actually be able to see the Pillars of Creation, just not as quite as grandiose as we see through the Hubble Space Telescope.
Yeah, now you'll see them right here as soon as I get to the proper, I can get my screen over here, pull this thing down. There they are.
There we go.
We had some plane go by here, by the way. Anyway, so there they are, the Pillars of Creation right there. So this is a what's called an emission nebula. This star cluster up here, it's an open star cluster. It's exciting what's largely hydrogen gas, some oxygen too, but hydrogen gas, and it's exciting the gas to a higher energy state, and then it's re-emitting the light. And that's what we're seeing here. So we're actually seeing, this is not reflected light. This is gas that's actually emitting the light, hydrogen gas mostly, that's re-emitting this light. And all nebulas, all stars were formed in nebulas, including our sun.
Mm-hmm.
So anyway, this is one of the real beauties of the southern Milky Way, the summer Milky Way, low down in the southern sky near the center, in the direction of the center of our galaxy.
What's
so go ahead, Curtis.
So you've done 20 seconds here. Is it still look better if you did a minute to get more definition?
No, I think this is about as good a picture as you can see. When I photograph this, if you go on to my website, earthandskyimaging.com, or the Wyoming Stargazing website, and look at this image. That image was probably taken over about 7 or 8 hours, but it is in color. It's in color. And so the black and white image that we have here is, but I've been photographing this, and I probably have maybe now 40 hours on this image, because what I want to do is get the detail of this. And the way you get the detail is you just take a zillion amount of hours, so that when you blow it up, there's no noise at all. It's all, so I'm going to blow it up here some more.
Yeah.
And you blow it up to such an extent that that there's no noise, and then you can bring out the detail using some software tricks. But another, for our purposes, this is as good as the image we're going to see.
And so we were, you want to blow that up one more time, Mike, so we can see the pillars. So we mentioned the Pillars of Creation earlier, and Mike mentioned that all stars are born out of nebulae, like this one. And so these pillars right in the center here, I know they look really small, but they're several light years long. So each light year is 6 trillion miles. I can't remember the exact length of these, but it's 2 or 3 light years. And I'm going to zoom in a little bit more, Mike. We might even be able to see the stars that are forming at the very tips of those pillars. Yeah, so these kind of bright patches at the tips there.
Fuzzy there, area there, yeah.
Yeah, so they're literally baby stars being born out of these enormous pillars of gas. So it's mostly hydrogen gas, some helium gas, and then trace amounts of heavier gases, heavier elements on the periodic table, but mostly hydrogen and helium. And so over hundreds of millions of years, stars will form just because of gravity collecting the gas, making it hotter and hotter and denser until nuclear fusion begins and the core of a star is born. And so the cluster of stars that Mike pointed out is no exception. That's a big cluster that formed out of this nebula.
Yeah, and the sun was probably born in a cluster like this, an open cluster that aren't hundreds of thousands of stars, hundreds of stars. The other thing, let's see what I was going to say here. I lost my thought. We'll pick it up again in the next picture.
Yeah, it's fine. Mike, do you remember the distance to M16? I can't remember.
I know what I was going to. Most of these are about 3,000 to 4,000 light years away, and what I was going to give you an idea of what a light year is. Our nearest star is 4 light years away, other than the sun, of course. And if the Earth and the sun were 1 foot apart, that star would be 85,000 miles away. So that gives you an idea about what a light year is. It's huge, and our solar system is measured in light hours, in light days, not light years.
Yeah, and if you want to include the Oort cloud, maybe a couple light years across from end to end. The Oort cloud is a maybe hypothetical, maybe real spherical shell of debris left over from the birth of the solar system. It's theorized to be the origin of long period comets, like comet Neowise that just came by, which has a orbital period of something like 6,800 years. And so this big spherical shell that encases the solar system, kind of like a huge snow globe, might be as much as 2 light years across. So the full solar system, including the Oort cloud, if it's really there, might have a radius of 1 light year, 6 trillion miles.
Were you able to image that through the telescope?
I don't know if anyone has ever imaged anything in the Oort cloud.
Oh no, I was thinking of Neowise.
Neowise.
Yeah.
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 Mike got some exquisite images of Neowise. I think just with his cameras, right, Mike? Not through the telescope.
Yeah.
I've taken some pictures with the telescope, but it's not as effective as just a regular camera because my focal length of even my smallest telescope is 900 millimeters, and the field that comet had a huge tail, and you wanted to photograph it about at 100 millimeters
Sure.
because of the size of the tail.
Yeah.
And I got a picture of it over the Tetons one night, and but I took it at 100 millimeters. Yeah,
I bet that was a nice shot.
The 900 millimeter picture I took with my telescope my telescope just shows the very head region. The field of view is too small to show the whole magnificent shape of that particular comet.
Mike, your audio is kind of cutting out a little bit. I'm not sure if.
Okay.
There you go. That's a lot better. Right
Yeah,
there.
it's all right. Maybe it's partly because of where I'm sitting. So I was just checking my notes here. You want to, since we're in this neighborhood, we ought to look at some other ones right down in the same place.
Yeah, it sounds great.
Check out M20.
Or 22.
Sure.
Well, that's a that'll of course be another star
globular
cluster globular, yeah. But we'll, why don't we try, look at one more of the, these magnificent nebula
Oh,
that are
sure.
down in this area.
Yeah.
I've got to change my screen here. I'm not going to bother. Well, maybe once this evening I'll do it this way. So I'll change my screen. I'll stop sharing, and I'm going to share this screen, which is my control system. For those of you who have been watching these before, you'll have seen this. But this is the screen. It's called SkyX, and it controls the telescope mount itself. So what I'm going to now do is type in M20, excuse me, M8 for the next nebula, the Lagoon Nebula.
Lagoon
I'm going to
Nebula.
hit find, and you can see it just moved. This red spot is where it is. I'm going to hit this button, and now it's going to say it's going to go there. And it didn't have very far to go because it's right next door.
Yeah.
And I'm going to stop sharing this, go back to my camera screen, and I'm going to, I've got to change the sharing. Oh, there we are. Okay. Now we're going to take a similar 20-second picture of that, and we'll see another one.
So this is another emission nebula, but it has a quite a different shape than the one we just saw.
Also has a star cluster in it.
Helps you focus.
So there it is.
Yeah, nice.
Yeah, so this is a star cluster, open star cluster, again, illuminating this cloud of gas and dust that creates this nebula is. And all this gas and dust, there's another, that's another well, semi-mystery, but semi-understood too. How did any of this happen? How did anything other than a perfectly uniform background happen? Because if the universe, which was perfectly uniform at one time, when at the very origin of the Big Bang, stayed that way, none of us would be here. But it was actually quantum fluctuations in the time frame of literally so small that it's inconceivable to actually talk about the time here. But small quantum fluctuations, which are constantly happening and disappearing, caused during the cosmic inflation actually remain. And these tiny little fluctuations cause small perturbations in the uniform density of matter, and they coalesced and created the first stars. And then the first stars, which were all hydrogen and made out of hydrogen, they lived there, what were at that time very short lives, because they tend to end up being very large. They blew up into supernova and created more elements. All the elements in the world other than hydrogen, helium, and a little lithium were created by the stars. And these, but the origin were actually that caused all of the structure in our universe were quantum fluctuations early in the at the time of the Big Bang. But getting back to the nebula here, this is this is a beautiful nebula, and it's quite colorful. If you photograph this in color, you see reds. Most of it is red in a true color image because hydrogen emits in the red. There's some oxygen. My image, a lot of the images of these type of things are done in narrowband, and mine using what's called the Hubble palette makes hydrogen green, and it does look like a lagoon, as the name fits.
I've got that one up, Mike, if you want me to show everybody.
Okay, sure.
And so Mike was just talking about his image of the Lagoon Nebula, and I'll show you what that looks like here. There you go.
So that's the center part of that image that we were just looking
I
at.
can't hear you, Mike.
Yeah. This, so the
There you
colors
go.
in this is called a false color image. And the reddish color is due to sulfur. The blue in this image is oxygen emission, and the green is hydrogen. So the atomic filter images, which most of the Hubble images are done in this color scheme. But they give a lot more information because you're actually seeing what's creating the various colors. You can relate them directly to the elements that are involved.
Nice.
Yeah, that's a classic picture.
How many hours of imaging?
This was, these are fairly bright because you can see these with your, well, not with your naked eye, but you can see these with binoculars. This was probably on the order of 10 hours of imaging, though.
Cool.
Probably not done in a single night, several nights, but I've been taking some pictures of some objects, which I'm going to be posting shortly, that are 70 hours of imaging because they're really dim. And the other problem, the nice thing about the narrowband images is that there's a lot of detail in it. You can see a lot of structure in it. But what you're doing is eliminating most of the light. And so it takes about 5 times the length of time to get an atomic filter narrowband image than it does a true color image.
Sure.
That's why these images take, part of the reason why these images take so long.
Thanks for explaining.
Yeah.
Should we go on to some globular clusters, maybe?
Sure. Yeah. Well, right down here, so we may as well look at M4, right?
Yeah.
Okay. So I'm
I'll let you
going
share
to
again.
leave that screen the way it is, and I'm going to just switch to my. I'm going to do this without letting you see it happen. I got to find. Oh, here it is. The right screen. We're going to go to M4. M in this case stands for Messier, and who cataloged 110 objects in the 1700s, and he didn't know what all these things were or had any concept of how far that way they were, but it's a wonderful collection of objects, and this just happens to be the 4th of these objects. So now I'm going to tell the telescope to go there. Yeah, everything these last 2 nebula were right in the middle of the Milky Way, right in the brightest part of the Milky Way, low down in the southern sky. This is this is off to the center. This is above the planar, the Milky Way plane. It's part of what's called the bubble of the halo, I guess is what it's called. And so now we'll take a picture of this. These are fairly bright, so it won't take quite as long an image. So I'll take a 10-second image of this one, and we'll take a picture. Then there's, before we leave this area, we'll look at a globular. Well, this is a globular cluster too. It's not the densest globular, but it's still quite pretty. There it is. That's M4.
Oh, we can't see it yet, Mike.
I thought I had shared it. Okay, I guess I've got to get back to the Zoom screen. Oh, I know why, because you took over the sharing. So I got to redo the sharing. That's
Yeah, you should be able to now.
Yeah, okay, got it. Okay, there it is.
Nice.
Yeah, so a couple 100,000 stars all packed together with the distances between the planets in our solar system as comparison. So these stars are just light hours away from each other.
Yeah, and we would never exist if our sun was a part of one of these globulars, because the stars would just be too disruptive. In fact, our sun is not in any kind of cluster at the moment. It was once most likely In fact, there's been people trying to figure out what our son's daughters and brothers, or not daughters, but sisters and brothers stars are might be based on just the motion of the sun over the millions of years in the last in the billions of years since it was created. But it would never have been in one of these, because these things are would have been the stars would have been way too disruptive. We would never form planets, stable planets in where you're dealing with stars that are that close together.
Yeah, it would have just been too strong a gravitational field from these other stars, so planets wouldn't have been able to form around them.
And
oh, go ahead, Mike.
You want to do M22?
Oh, I mean, we could skip M22 and just go right to M13.
M13. Okay,
Yeah.
we'll jump
I mean,
to the.
nothing beats M13.
Nothing beats
Sure.
M13. Right. Okay. So
Yeah.
let me jump to M13.
Yeah, so M13 is the great globular cluster in Hercules. It is visible to the naked eye if you have 20/20 vision and know right where to look. I can see it on moonless nights here in Jackson, and like the last object, it's a tight cluster of a couple 100,000 stars, but this one really shines brightly, and even through a moderately sized telescope, it's got a wow factor to it. And as Mike is moving the telescope and getting over to that, I'll show you a picture that Mike took of this object. Or maybe we'll wait since he's almost ready to show us this picture.
Yeah, it's coming up right now. But yeah,
we'll take a look at your photo.
Okay, I'm going to dim the set. So I'll leave it. I can change the relative brightness, but here's you can see the extent of it. But now I'm going to dim the center part so we see more detail, and I can zoom in a bit.
Yeah, that would be great.
And yeah, and this is another one of these things where X does mark the spot. See, the center part seems to have a X pattern to it for no obvious reason. Just happens.
It's funny.
Yeah, but it's a beautiful. It's a classic, great Hercules globular star cluster.
Now let me show you Mike's process picture,
which will have some color in it too. You'll see some color in the stars.
Great.
Let's see. Can you guys see that now?
Now I think you're still looking at me.
Okay.
Maybe I need to stop share.
I can see it.
All right, there it is.
Yeah.
Wow, Mike, amazing detail on the car.
Yeah. And you can see there's these clusters they're some of the oldest stars in the universe in these clusters, and they were formed. There's stars in here that are 10 billion years old, and if you look carefully, you can see there's definitely color in here. There's a lot of these stars have definitely a yellow and orangish tint to them.
And Mike, you were mentioning earlier how the chance of planets actually forming in these clusters is probably impossible, but very low likelihood. Interestingly enough, when the big radio telescope in Puerto Rico came online, Arecibo, the SETI Institute decided to send a signal to this object, M13, because it just happened to be located prominently up in the sky during that time of year, knowing that the chances that there was, any intelligent life here is very unlikely because it's a globular cluster. But nonetheless, a signal was sent to M13, but it's going to take 25,000 years for that signal to reach M13. And by the time that signal reaches the location that it was sent, M13 will have moved a little bit. And so it's not going to hit it dead on, but maybe out in the outskirts of some of these stars. But even there, the chances of planets forming around there is pretty low likelihood, just because of the strange gravitational field by so many stars in the same area, but also for the other reason that Mike just mentioned, that these stars are really, really ancient stars. They're 10 to 12 billions of years old, which means that they're mostly just hydrogen and helium. These stars didn't form out of the leftover remains of a previous generation of stars. These stars formed from the original hydrogen and helium left over from the Big Bang. And so there aren't any or very low amounts of heavy elements in this cluster to form planets in the first place.
Like oxygen and carbon and good stuff like that.
Yeah, iron, yeah.
Yeah, it's
Want to go on to some galaxies, Mike?
sure.
I'll stop my share so you can share your screen again.
Okay, yeah. So we'll go to, I'll get my this screen up. Maybe we'll share this screen one more time. Let's see, share screen. Here, look. All right, so here's the control screen again. So a galaxy in this area, we could try, we've been looking at M51. And
yeah, I mean, that's
Ooh.
hard to beat that too.
Nice.
yeah, so let's go back and look at that. M51, the Whirlpool galaxy, and I'll hit find. And it's back when we started these sessions, it was over in the eastern sky, but it's no longer. It's actually very close to overhead right now. So now I'll just hit to find it. You see the red dot. I see the yellow dot moving over to the red dot. In fact, yeah, it's actually in the western sky right now.
And so this galaxy is right off the end of the handle of the Big Dipper, part of Ursa Major. And right now it's located beautifully over the Tetons here in Jackson.
We could pull up the Hubble version of that.
Yeah, it's pretty awesome. Although we'll actually see some really nice detail just with this 20-second exposure that Mike's going to take, or whatever time he does.
Yeah.
And we'll see the spiral arms. You can actually see the spiral arms just looking through a large telescope on a moonless night. Through our 20-inch and 25-inch telescopes, you can see the spiral arms quite nicely.
You're lucky.
We are indeed. Yeah, so this is a big spiral galaxy like the Milky Way.
I got a little glitch here. I've got to, since we're looking in a different part of the sky, then I have to open up the observatory further in the north direction. It was open for the south, and now it's I've got to open it up in the north.
Gotcha.
Yeah. Okay, that should be good enough. I have to redo this picture. I see I got a big blank screen here because I was shooting right into the dome. Closed. Yeah, my picture of this, I don't know if Samuel, you want to bring that up, but my picture of this was 57 hours.
Yeah, I've got it up. I can want me to share it before we look at this?
Well, you'll see it here in 3 seconds. So
okay, yeah, I've got it ready to go.
Yep. Okay. Okay. So there it is. I'm going to brighten it up some.
Yeah, there you go. That looks great right there.
Yeah. Yeah. This is actually two galaxies that are gravitationally bound to each other. Here's one and here's two. And as Samuel was saying, you can see all these spiral arms are places where where stars are being formed in this galaxy. These bright spots that you see here are not actually stars. They're clusters of thousands and thousands of stars that form clusters. And if in color, when we look at it in a second, you'll see a lot of these bright spots are actually red, which means that they're emitting hydrogen. They're hydrogen gas that's emitting light, and that means their stars are being formed in these areas. Just a comment now, since we're now looking at a galaxy, this galaxy is about 25 million light years away, which means that the light that's arriving at this telescope right now that we are looking at, that 20-second exposure, left this galaxy 25 million years ago. All the other stars, the real stars you can see in this image, are not in this galaxy. They're in the Milky Way. They just happen to be between us and that. To give you a scale, the Milky Way is 100,000 light years in size, and meaning the solar system, the sun, is about 25,000 light years from the center of our galaxy. So this is 1,000 times farther away. This is 25 million light years away, not 25,000 light years from the center of our galaxy. So, and that's one of the big things that happened during the 20th century, was figuring out how do you measure the distance? How do you figure out? So when Messier, this is Messier 51, when he saw this, he had no concept of how far away it was. And even 100 years ago now, people still didn't have a concept of how far this stuff was away. There was a real debate going on at that time that of what this stuff was, and people there was a strong group of people who felt, astronomers who felt, that everything in the universe was in our Milky Way, that this was a part of the Milky Way. This was a nebula in the Milky Way. And it wasn't until Hubble and the work that was done at Harvard that worked out a way to measure distance in long distances. You can measure distance for objects that aren't too far away, maybe tens of hundreds of, maybe even up to 1,000 light years, but based on parallax, where the Earth goes to the opposite side of the sun during different seasons, you measure the difference in angle to an object, and based on the separation of the two orbits between, say, spring, summer, and winter, and you look at the difference in the location, you can figure out, but that only works for things that are relatively close. For things that are 25 million light years away, that doesn't work at all. And you had to come up with something else called standard candles, where objects were known, the brightness of an object was inherently known, the true brightness. So once you know a true brightness of something, you can then infer its actual distance by measuring its apparent brightness. And one of the things that people do is something called the Cepheid variable stars happen to have a way of determining their true brightness. The other one that's used widely nowadays, not when Hubble was first doing this, but are a certain type of supernova, which are all pretty much the same brightness, all type 1A supernovas. Those are all called standard candles. And when you see one of these things and you can identify it, you measure its apparent brightness, you can infer its true brightness or distance by sort of the 1/r squared. The light drops off like the square of the distance. And so you can infer the distance that way.
Yeah, I mean, and that great debate was exactly 100 years ago. It was 1920.
Yeah. It was, and Hubble ended that debate essentially. Well, not immediately, but fairly quickly.
Yeah. And it's worth mentioning that those Cepheid variable stars, the relationship between their brightness and their pulsation rate, that wasn't worked out by Hubble. That was actually worked out by a woman astronomer by the name of Henrietta Swan Leavitt. At the time, women astronomers weren't allowed to have the same status as men astronomers. The women were known as computers. They were the ones doing the laborious mathematics, looking at all the data, figuring out the relationships, but got none of the glory. So they've been vindicated to a certain extent. And a lot of the great discoveries that were made during the last century, 1900s, we now know were made by these women astronomers. And Henrietta Swan-Leavitt has the distinguished honor of figuring out this relationship between the true brightness and the pulsation rate of Cepheid variable stars that unlocked the key to our understanding of the vastness of the universe. Without knowing those standard candles that Mike mentioned, Edwin Hubble never would have been able to figure out the distances to these spiral nebulae and determine that they were way past the boundaries of the Milky Way galaxy.
Yeah, we saw a picture in a talk just last week where one of Hubble's actual pictures of the Andromeda galaxy, where he identified a object as a Cepheid variable, and that was the key to unlocking the fact that the Andromeda was not hundreds of thousands of light years, but millions of light years away.
There's a terrific book called The Glass Universe by Dava Sobol about that work.
Yeah.
She also wrote Galileo's Daughter and Longitude, which is another terrific book about
one of my favorites.
Yeah.
So Mike, let me bring up your picture of M51 so we can really show all those star forming regions. And it's pretty cool. So those star forming regions that you mentioned, which we'll see here in red, are those emission nebulae that we looked at just a few minutes ago, like the Eagle Nebula and the Pillars of Creation.
But in a totally different galaxy.
But in a totally different galaxy. Yeah, not in the Milky Way, but in the Whirlpool galaxy. That's the
Okay,
common name.
I'll stop the share
galaxy.
here.
And hopefully everybody can see that now.
Yeah. So the reason you can see that there, a lot of the patterns you were looking at previously are here, but the key to this picture, to be able to bring it out and see the very fine detail in these inner little bands, was getting 57 hours of imaging so that I could bring out the detail in these by sharpening. And if you have, unless it's a perfectly good, the noise is really low, you sharpen, all you get is your sharpening noise, you just get a blur. So the key to get this level of detail is just countless hours of imaging that allows you to get that level of detail. And as you can see, there's a lot of red in this. The blue is scattered light, is off of clouds of gas and dust. But the red is emission. It's hydrogen gas emitting. And you can see there are just clumps of them all along these beautiful spiral arms. Now, by the way, all these pictures are available. We're not trying to make a sale, but if you want any of these, go to yeah, maybe we are. Go to Wyoming Stargazing website, and these are all available on the website, and you can purchase these, and at the same time you are benefiting Wyoming Stargazing.
And if you've never seen one of these images printed on a metal plate, you're missing out. They are pretty awesome.
Yeah, they jump at you. What it looks like on a metal plate is something similar to what you're seeing here, in the sense that it's luminous. Whereas you look at it printed on paper, it's not quite the same thing. Because paper can only be as bright as the whiteness in the paper, but the metal print just has a luminous quality to it that almost looks like it's emitting light.
Cool.
Leonardo da Vinci, eat your heart out.
Yeah. Yeah. But this is a classic, and it's not. The other problem with it is, from just a technical standpoint, it's small. This is only this distance here. This long distance is only about 8 arc minutes, and that means it's about a third of a fourth of the size of the full moon in the sky. And even my 20-inch telescope, full view of the 20-inch telescope with my camera, it is about the full moon. So this only fills a quarter of the size of the field of view of that telescope. So it is heavily cropped in this picture. And so when when you're taking a picture, you crop something, you're blowing it up, and you're losing detail in the process. So to get the level of detail here took a lot of work.
Mike, you had mentioned the bubble nebula being really good last week.
That was beautiful. Yeah, that's 7635. So why don't we looked at a couple of galaxies. We looked at one galaxy, but this is probably the prettiest galaxy we'll see tonight. There are others we can look at, but this is by far probably the prettiest one. Okay, so why don't you eliminate that screen, and I will go to the bubble, and I'm going to go back to my screen and type in. This one is New General Catalog NGC 7635, and we'll go and we'll find it. And actually, the telescope's going to flip to do that. It's you can't see the screen. I'm not going to bother showing it to you, but I will go. So the telescope's going to take a few seconds to get there, but not too long. It's got to go through. It's a German equatorial telescope, and in this case, it's actually going to point point right at the North Star right now, and it's going to flip around and look at this object where it was. The telescope is now going to be on the west side of the mount, looking east, and it was just on the east side, looking west. So what just did what's called a flop. Okay, so now we're going to share screen, go back to the camera screen, share. I get faster at this as the night goes on. And we're going to take a 20-second picture of this. Hopefully my dome is open far enough so we can see this.
We'll find out momentarily.
Yes. But this is interesting. This is a very unusual nebula. Yeah, and there it is. I'm going to. Oh yeah, actually, we're going to have to. It's
Just about
there.
bubble shape.
Yeah, yeah, yeah. Not as quite as good as we were seeing it the other night, unfortunately. It's what the bubble part of it is this shape right here, and it's a bubble of hydrogen gas that is being essentially moved apart. The solar wind from this bright star is causing the hydrogen gas to blow out like a bubble. And it's in narrow band, it looks like it's glowing in red because it's hydrogen gas and it glows in red. Yeah, we saw it better the other night. It may be partly, if I darken it, might be better. I don't know.
Yeah, we can't see as much detail like
that. It's better bright, but yeah,
that's a little too much.
I've blown it out. Yeah, I got it.
Yeah,
but yeah, not quite as impressive as it was the other night.
Well, I've got your image up of it if you want.
Okay, so yeah, okay, here it is. Okay, I'll stop sharing here.
That looks like a lot of hours.
That's a lot of hours too. Yeah, this is another narrow band image, meaning I printed this in both this is the Hubble palette version, which yeah, is strange, but Hubble, what they've done is they've made sulfur, which has the longest wavelength of the conditioned wavelength. Then comes hydrogen and oxygen. So they've made sulfur the red, and oxygen, hydrogen green, and oxygen blue. And so that's why that's where the colors are, and that's called the Hubble palette. But I've also printed this in a shade that's actually closer to the true colors, where the hydrogen is red, because hydrogen does emit in the red, and oxygen does emit in the blue.
In the green.
Yeah, I've got that right here too. I'll bring it up.
Okay, so here's another narrowband image, but done in the hydrogen palette, hydrogen red palette. And what this one looks like is a star, is a superhero. You know, what's the one that the guy's all dressed in red?
Iron Man.
Yeah. Well, anyway, but yeah. So you here this actually in this particular between these two, this one is a little more impressive. But you can see there's another picture which I don't think Samuel has, which is I've taken just for illustrative purposes. I printed this or took it in true color with just regular broadband red, green, and blue filters. And you miss a lot of the detail here. You still see the bubble, but you miss a lot of the detail on you. In fact, here it comes. All right, there it is. So that's the true color. There it is. See, so that's the true color version of that last image. But you notice how much less detail you're seeing out here. You are seeing the bubble, but inherently there's just less detail. And that's one of the reasons why a lot of the scientific images are taken in narrowband, because you get a lot more information about what's going on in the nebula. And it's in this case, it's actually a more interesting picture in the narrowband. It's also a lot longer, 5 times longer to take that previous image than this one, because you're letting a lot more light through those filters when you allow all the red, all the green color, and all the blue color to come through, rather than parsing it out. Because these narrowband filters have a pass-span of only 3 nanometers, so they're just extremely narrow. They only allow one particular wavelength that comes from one particular atomic transition in each of these 3 elements.
Michael, is the density of stars around there primarily because of the collapse of hydrogen and that?
Well, okay, yeah, and that's the other thing about the difference in these pictures. You'll notice the stars dominate this picture so much more, because the density of stars here. There is a density of stars in this nebula, and there are clusters of stars in the nebula. But most of these stars have nothing to do with this nebula. They're just there. But they look so much more apparent in this image because we're allowing all the light from these stars to get into the picture, whereas the narrowband is just. And so, in many cases, the nebula pictures are nicer without all the stars, because the stars kind of also distract you from the beauty of the nebula. And so that's another reason why the narrowband images are more attractive. In fact, I've just found a trick, or not a trick, but a technique to take all the stars out. You see, look at the difference. You see, there's as many stars in this picture as there were in that other one, but because we're only allowing a fraction of the light through these narrow filters, the stars just don't dominate, and the nebula stands out more. But I've just determined a technique to take out all the stars, so there's not a single star in these. And it's there are some images which that has an interesting effect to it too. But you can also use that in processing these pictures by taking all the stars out and then processing the nebula. Then you can put the stars back in, but you're not processing the stars, you're just processing the filter. And there's a fellow who wrote this neural net, of all things, a neural net program to suck out all the stars, and it does an amazing job. I just discovered this in the last week, and I've been playing around with it, this tool. But so that's the kind of things that I get off on, doing stuff like that. Yeah. Yeah, I've told people that I enjoy everything about this hobby. It's a hobby for me. I mean, I don't make any money at this. I call it a business, but it really isn't. But I enjoy taking the pictures. I enjoy then making them into actual photographs, prints, and so I enjoy the whole scene.
That's great. Thank you, Michael.
Yeah, really appreciate it, Mike.
A lot of
Does
hours.
does anybody have any requests out there for any object they'd like us to take a picture of right now and show you in real time?
Well, we haven't looked at any of the planetaries tonight.
Oh yeah, let's do a planetary. That's a great idea. Maybe the Ring Nebula,
Yeah,
Yeah.
we could look at the ring and the, yeah,
dumbbell.
yeah. Okay, so
Yeah,
let
great
me,
idea.
okay, let's, why don't you undo your screen and
There you go.
I'll do M57. They're
Sounds great.
fairly close to. Yeah, I'm about to produce a new version of M57 too. This one is M57. It's interesting because we'll go ahead and take a quick look at it. And it's actually visible. It's one of the nice objects you can see with your eye, naked eye, through a telescope. But I've actually taken a picture now of it that involves 70 hours of imaging. And so why would you use 70 hours of imaging for something that's so bright that you can actually see it with your naked eye when you look through a telescope? And the reason is you're not seeing much of it when you this image. You're seeing, it's interesting, but it turns out the image that I'm going to post shortly has a lot more detail in it. And this thing is a lot larger than it appears in this particular picture. So I'm going to, I gotta go and share a screen and share my picture screen again, share it. And we'll take I don't need 20 seconds, I'll do 10 seconds. This is a very small object. This thing is only on the order of about an arc minute, which is 1/30th the size of the full moon. But there it is. So we can blow it up a little bit. So you see, what you're seeing here is, just to illustrate a point, what you're seeing here is my full screen. In fact, this is, you're not seeing the full screen. Let me go down to this. No, that's too small. I lost it over here. Okay, that's the full field. That's the field of view of this telescope. So you're seeing this is a 20-inch telescope.
Yeah.
And this is all this object actually occupies in this. So this is a tiny. So this whole distance here is about the size of a full moon. And so this is a tiny fraction of the full moon. You know, an arc. A full moon is 30 arc minutes, and this is on the order of one arc minute. But turns out this object is actually a lot bigger than this, and it's actually goes out about this far. But you won't see it in a narrow. You have to do it in narrow band and do 30-minute exposures to see it. I'm going to blow it back up again so we can look at the center of it. But so this is what's called a planetary nebula. And it's not has nothing to do with a planet though. What it is, they call the astronomers of eons ago called this a planetary nebula because it was round, but it has nothing to do with a planet. It's the leftover remnant of a star, about the size of the sun. And the remnant of it, I'm going to blow it up one more notch. The remnant of the star, the leftover star, is right there. It's called a white dwarf, and it's actually a star that's extremely dense, packed as close as electrons can get to each other, but it's all it is glowing carbon, and it's not. There's no nuclear reaction. So what's happened is the star that was there once, which burned through all its hydrogen, probably then collapsed again, heated up the helium enough to start another nuclear reaction, burned through all its helium, and then all that was left is carbon. And it squeezed the carbon, but it didn't have enough, the gravity was not enough to squeeze carbon hot enough to start another nuclear reaction. And so the nuclear reaction stopped, and the star cools off, and the gas expands into what's called a planetary nebula. And so this is probably several light years. Say I'll just wing it and say it's 4 light years across. But so this is huge compared to the size of the original star. But as I said, I've just finished a picture of this where there are outer bands of this that aren't shown here that are again the leftover gas and dust from the star, and they make this quite a bit larger than it appears in this image.
I can't wait to see it.
Yeah,
Yeah.
it's interesting. It's interesting. There's another one that's very close by, and while we're into this, there's a little more detail in this, and it's a little larger. It's M27. It's called the dumbbell. Yeah,
Sure.
the numbers are very similar. It's 27 versus 57, but they're totally unrelated to each other. And we'll just have it go over there quickly, and we'll take a quick picture of it.
And this is what we have to look forward to for our solar system. Eventually, our sun will run out of its hydrogen fuel and cast off its outer layers just like these stars did, and it'll become a white dwarf, and the solar system will be reduced to this glowing gas cloud.
Yeah.
The other
And with
planets will all get destroyed, and
with a little white dwarf in the middle. So,
yeah.
And so this is the dumbbell nebula, and it's again all of these are different shapes, but they all tend to have some circular symmetry to them. But this is the remnant of this is the white dwarf in the middle, and this has some very nice color to it too. And this is actually a more interesting, except for my new one. This has a more interesting look to it than M57 does when printed, because it's there's some nice red and green in it, because the hydrogen red gas and the there's oxygen in here, which gives it a blue-green tint to parts of it too. It's called a dumbbell because this shape here, you see how the shape goes in, then out, and then in, and then out. And so it sort of looks like a dumbbell, and that's why it has that name.
And this gives you a little bit better idea of what a lot of these planetary nebula actually look like. A lot of them have this dumbbell shape where the gas is being expelled bilaterally, two different ends of the star in opposite directions and expanding out as it goes. As opposed to the ring nebula, we were having a top-down view of it. So we just saw the bright outer ring as opposed to the dumbbell shape.
Yeah.
Well,
Okay.
it's about 11:30. Anybody have anything else they're dying to see? Well,
Any questions? Any more questions?
yeah. Any questions about any of these objects or anything else we've mentioned?
Yeah. Okay.
Well, thanks again, Mike. That was a lot of fun. Really appreciate your time.
Yeah, no, I enjoy it too.
Thanks, Mike.
Sure
Great
enough.
commentary, great
Yeah,
pictures.
Curtis, it was great to see you.
Yeah, it's good to see you too.
Yeah, thanks for joining us.
I appreciate it. I'm gonna bring more people next time.
Yeah, please do. Yeah.
All right. Have a good one. Thanks for the show.
Curtis. Take care. Yeah, you're
You too.
welcome.
Bye-bye.
Well, thanks again, everybody, for being here for another virtual stargazing program. Hope to see you next time, and please spread the word. Hope everybody has a great night.
Okay, good night.
Nighty night. I see you. Susan, good night. I hear your voice.
Good night.
Bye.
Okay.
Yeah.